Hello, welcome back. Today we are going to learn how to factor polynomials by grouping. The first concept I'm going to cover is the idea of multi-term GCFs. Let's think for a moment about what that would require. Well, for the GCF to have more than one term, each term in the polynomial would have to be multiplied by another polynomial. Like this. Here we see that both terms in the binomial, 5x plus 13, are being multiplied by the entire binomial 4 minus 7x separately. If we wanted to factor this expression, the GCF would be the binomial 4 minus 7x. So when we pull it out, we would have to remove it from both terms. Doing so leaves us with an expression of two binomials being multiplied together. From here on out, this is what factored form will refer to. Now we will do a more complicated example. Let's do the same thing on an expression with three terms being multiplied by a binomial. First, we factor out the binomial, leaving it on the side, and then we put the remaining monomials next to it. With that understood, let's now back up a step and apply a similar procedure. Now we're going to reduce the binomial 42x cubed minus 6x squared added to the binomial 35x minus 5 to factored form. Your first instinct might be to add the binomials like we did in the last unit, but instead let's try pulling out a GCF from each first. As you can see, I've listed the GCFs of each binomial, and upon dividing them, we get an expression that hopefully looks familiar. If you haven't noticed yet, the expression we are left with has a multi-term GCF, so let's factor that out. Now we have taken two binomials that were being added together and reorganized them into factored form. If we had instead followed our instincts and added them, we would have gotten a cubic polynomial. So if we were asked to put a cubic polynomial into factored form, we could try doing what we just did. Let's try doing just that on this polynomial. First, we divide it up into two binomials, like this. Then we pull out the GCF from them. Next, we make sure the binomial GCFs match. And they do, so we factor them out. And just like that, we are done. We have reduced this cubic polynomial to factored form. Let's do one more example with two variables this time. First, we group the polynomial into two binomials and pull out the GCFs. But we will see this does not create matching binomials. This is a problem that you will sometimes encounter if the polynomial is in more than one variable. To combat this, we will have to be a bit more careful in choosing which terms to group together. Instead of just using adjacent ones, let's notice that terms 1 and 3 share several factors, notably 2x squared, and so do terms 2 and 4 with 3y squared. So now we'll try grouping these pairs of terms together and pulling the GCFs out. And they look very similar, but not quite equal. No worries though, as there is one more trick we can pull. After noticing that the binomials are additive inverses, meaning either 1 times negative 1 equals the other, so if we just added a negative sign to either GCF, we would have equivalent binomials. In this case, I chose the latter, but either would have worked. And now we see that the binomials indeed match, so we can just factor them out. And after all of that, we have done it. This cubic is officially in factored form. With that, there is only one more thing to this topic, which is the fact that you will sometimes need to group a polynomial that is not primitive like the one on screen. For a reminder on what that means, watch my previous video in this series. In the event that this happens, you must simply factor out the GCF at the beginning and follow the process as normal, like here. But don't forget to keep the GCF besides the binomials in factored form, like so. So to quickly summarize the procedure, you first pull out any GCFs if applicable. Then group the polynomial into pairs that have similar factors. Next, you factor out the GCFs from all the binomials and change the signs if necessary, and repeat those steps until all the binomials match. Then, finally, you factor out all the binomials, leaving the rest of the terms on the side. And you can always check your work by redistributing everything if you aren't confident. And that's it. Now let's do some comprehension questions to get some extra practice. Pause to try them yourself. And here are the answers. Thanks for watching. I hope you enjoyed and learned something new. Don't forget to leave a like and subscribe. See you next time.